Imagine waking up to a world where your smartphone, GPS, and even the power grid have been knocked out by an invisible force from space. This isn't a scene from a sci-fi movie. It's a real threat we're facing right now. Hey everyone! Welcome back to our channel. Today, we're diving into a crucial and urgent message from none other than Bill Nye, the science guy. Recently, Bill issued a final warning about the potential devastation of an extreme G5 solar storm. What does this mean for us, and how can we prepare? Let's break it down. A G5 solar storm, also known as a geomagnetic storm, represents the most intense category of solar storms as classified by the National Oceanic and Atmospheric Administration, NOAA. These storms originate from the Sun, where massive bursts of solar wind and magnetic fields escape from the Sun's outer atmosphere, known as the corona. This release, often triggered by solar flares or coronal mass ejections, CMEs, propels highly charged particles across space. When these charged particles reach Earth, they interact with our planet's magnetic field. This interaction can create dramatic and beautiful auroras near the polar regions, lighting up the night sky with vibrant colors. However, the impact of a G5 storm extends far beyond these visual spectacles. The intense energy and charged particles can induce powerful electric currents in the Earth's magnetosphere and ionosphere. This process can have severe consequences for our technological infrastructure. For instance, the induced currents can overload and damage power grids, potentially causing widespread electrical outages that can last from hours to weeks, depending on the severity and preparedness of the grid infrastructure. Satellite operations, which are crucial for communication, navigation, and weather forecasting, can be disrupted as the storm interferes with their electronic systems and orbital paths. Moreover, radio communications, particularly those that rely on high-frequency signals, can be significantly impacted, leading to blackouts in various services including aviation and maritime operations. GPS systems, essential for everything from personal navigation to military operations, can also experience inaccuracies or complete failures. Bill Nye, known for his ability to convey complex scientific concepts in an accessible manner, has recently heightened awareness about the imminent threat posed by G5 solar storms. Drawing upon his extensive knowledge of solar phenomena, Nye emphasizes the cyclical nature of solar activity, wherein periods of heightened solar activity increase the likelihood of powerful solar storms, particularly those classified as G5. With the current phase of heightened solar activity, Nye's message serves as a timely reminder of the need for vigilance and preparedness. By understanding the intricate mechanisms driving these solar disturbances, we can better grasp the potential magnitude of their impacts on Earth's technological infrastructure and societal systems. Nye's warning resonates with urgency as he underscores the critical importance of scientific literacy in navigating the complexities of solar phenomena. Through education and awareness, individuals and organizations can equip themselves with the knowledge necessary to anticipate, mitigate, and respond to the effects of G5 solar storms. Furthermore, Nye advocates for proactive measures aimed at minimizing the potential disruptions caused by these extreme solar events. Whether through advancements in forecasting technology, the development of resilient infrastructure, or the implementation of emergency response protocols, Nye stresses the importance of taking tangible steps to safeguard against the adverse consequences of G5 solar storms. Nye's call to action serves as a clarion call for collective action, urging stakeholders at all levels to prioritize scientific understanding and preparedness in order to mitigate the risks posed by G5 solar storms and ensure the resilience of our interconnected world in the face of these formidable natural phenomena. The potential impacts of a G5 solar storm are significant. Power grids could be severely affected, as the storm could induce electric currents in power lines, potentially leading to widespread blackouts that could last for days or even weeks. Communication networks, including satellites and ground-based systems like GPS and Internet services, could be disrupted. This could have a ripple effect on various sectors, from personal communications to global business operations. In addition to the disruptions to technological infrastructure, the aviation industry faces significant risks in the event of a G5 solar storm. Airplanes heavily rely on GPS and other communication systems for navigation, routing, and communication with ground control. However, these critical systems could be compromised or rendered unreliable during a severe solar storm, potentially leading to navigational errors, communication blackouts, and compromised safety for passengers and crew. Moreover, the health risks associated with increased radiation exposure pose a considerable concern for individuals in aviation, particularly those at high altitudes. Astronauts aboard spacecraft and satellites in orbit are particularly vulnerable to heightened radiation levels during solar storms, as they lack the protective shielding of Earth's atmosphere. However, even airline passengers flying at cruising altitudes may experience elevated levels of radiation exposure during such events. The implications for aviation safety and passenger well-being underscore the importance of proactive measures to mitigate the risks posed by G5 solar storms. Airlines and aviation authorities must prioritize contingency planning and risk management strategies to minimize the impact of solar-induced disruptions on flight operations. Additionally, enhanced monitoring and forecasting of solar activity can enable airlines to adjust flight routes and schedules preemptively, thereby reducing exposure to potentially hazardous conditions. Given the potential magnitude of the threats posed by G5 solar storms, Bill Nye underscores the critical importance of preparedness at both governmental and individual levels. Governments and utilities are urged to prioritize strengthening infrastructure resilience to withstand the impact of such events. This involves not only fortifying physical infrastructure but also developing more advanced forecasting tools and implementing effective response strategies. At the individual level, proactive measures can significantly mitigate the risks associated with G5 solar storms. Nye advises individuals to assemble emergency kits containing essential supplies, such as food, water, medical supplies, and communication devices. Additionally, having backup power sources, such as generators or solar panels, can help sustain essential services during prolonged power outages. Staying informed through reliable sources is paramount in navigating the complexities of solar weather events. By staying abreast of updates and advisories from reputable sources, individuals can make informed decisions and take appropriate actions to protect themselves and their communities. Furthermore, Nye advocates for continued investment in space weather research and technology. Advancements in predictive capabilities and protective measures are essential for enhancing our ability to anticipate and mitigate the impacts of G5 solar storms. By fostering innovation and collaboration in the field of space weather science, we can better prepare for and respond to the challenges posed by extreme solar events. Nye's message emphasizes the importance of proactive preparedness and collective action in safeguarding against the potential disruptions of G5 solar storms. By adopting a comprehensive approach that integrates infrastructure resilience, individual readiness, and scientific innovation, we can enhance our resilience and minimize the societal impacts of these formidable natural phenomena. International collaboration is essential for developing robust defense mechanisms. By understanding the science and taking proactive steps, we can mitigate the risks and protect our technology-dependent world.